In today's video lesson, we will be learning how to classify real numbers. All real numbers can either be classified as rational or irrational. Let's get started. We're going to first start with a little warm-up because some of these types of numbers and expressions we're going to be asked to classify as either rational or irrational. So if this isn't in your notes, please write down a few of these examples. All right, let's get started. The square root of 36. We know what that is. We know it's 6 because 6 times 6 is 36. On this next one, it asks you to evaluate 5 plus the square root of 16. Well, you know the square root of 16 is the same thing as 4, and so really this is saying 5 plus 4, which equals 9. The next one, a 4 is sitting next to the square root of 49. There's an invisible operation that you don't see. It's multiplication. So really this is saying 4 times the square root of 49. Being that this is 7, this is 4 times 7, which is 28. So far so good. Here I have the square root of 9/25. On this example, you should be able to evaluate it without a calculator. Now, do you see how the square root symbol is around everything, the numerator and the denominator of this fraction? Really, I could separate this, and because the square root is all around everything, I could write it as a square root over 9 and the square root over 25. I could just pull it apart and write it separately. You know the square root of 9 is 3, and the square root of 25 is 5. So, the square root of 9/25 is equal to 3/5. And that's just because 3/5 times 3/5 is the square root, is 9/25. Same thing goes for this. 6 times 6 is 36. 3/5 times 3/5 is 9/25. Let's try this next one. The square root of 100 divided by 2. Well, we can evaluate the square root of 100. That's 10. And if we divide it by 2, we get exactly 5. Let's try this one here without a calculator. The square root of 1 over 64. Again, do you see how the square root symbol is around the entire fraction? Well, that means that the square root symbol is really in the numerator and it's also in the denominator. If I separate it, you can see that. The square root is around the whole thing, so it wants us to take the square root of the numerator and the denominator. Well, the square root of 1 is just 1 because we know 1 times 1 is 1. And the square root of 64 is 8 because 8 times 8 is 64. So the square root of 1/64 is equal to 1/8. And that's just because 1/8 times 1/8 is 1/64. All right, so we can actually evaluate some of these that look a little bit tricky without a calculator, just by taking the square root of the numerator and the denominator, like we did here. Okay? Now this might be something that you haven't seen before. This is called a cubed root. So what this is asking is, what is the cubed root of 27? So kind of like square root, the square root of 36 is 6 because 6 times 6 is 36. The cubed root of 27, you need to think, what number times itself times itself times itself is equal to 27? Well, that's easy, 3. 3 times 3 times 3 is equal to 27. So that means that the cubed root of 27 is equal to 3. 3 cubed is 27. Let's try this one. What is the cubed root of 8? So think, what number multiplied by itself 3 times is equal to 8? Well, that's easy. 2. 2 times 2 times 2 is 8. So the cubed root of 8 is equal to 2. This last one. What is the cubed root of 64? So think, what number times itself times itself times itself is equal to 64? You're right, 4 times 4 times 4 is 64. So the cubed root of 64 is equal to 4. All right, so now we've done some evaluating. Notice how every single one of these numbers that we have here were easily evaluated to either a fraction or a whole number. 6, 9, 28, 3/5, 5, 1/8, 3, 2, 4, every single one of them. That makes every single number or expression on this paper to be rational, because every single one is either a whole number or a fraction, and all whole numbers and fractions are rational. All right, let's get started with some classifying. So all real numbers, every number that you could probably think of is a real number. They can either be classified as rational or irrational. They can't be both and they can't be neither. So let's first look at rational numbers. There are a lot more rational numbers than there are irrational. So rational numbers would be numbers like our whole numbers. And whole numbers are like the numbers 0, 1, 2, 3, 4, 5, and so on. The other set of numbers that's rational would be our natural numbers. And that would be numbers like that you naturally just count with, 1, 2, 3, 4, 5. So they're a lot like whole numbers. The only additional number that belongs in the whole number category would be the number 0. That's not a natural number because we don't count with 0. The other types of numbers that are rational would be integers. And integers are all of your positive and negative numbers, including 0. So if you want to write down some examples, you can. That's fine. The other type of numbers that are in the rational category are decimals. But be careful. Specifically, the only kind of decimals that are in the set of rational numbers are decimals that terminate and decimals that repeat. Okay, so decimals that terminate, they stop. Okay, so like the decimal 0.75. And then decimals that repeat would be like decimal like 0.3 repeating. Those are the only kind of decimals that are rational. So notice I didn't say that decimals that go on forever and don't repeat, those are not rational. Okay, so just these kind of decimals. The other kind of numbers that are rational are fractions. All fractions. Any number that can be written as a ratio of two integers, a fraction, a mixed number, a negative fraction, an improper fraction, any kind of fraction you can think of, they're always going to be rational. That's important. And then the other kind of numbers that are rational would be like your perfect square roots. So numbers that you know the exact answer to, like the square root of 16, the square root of 25, the square root of 100, the square root of 36, all of those perfect square roots. Even the square root of 81 over 121. That's rational. Why? Because you can evaluate it as a fraction. So remember, like we were doing in our warm-up, the square root of 81 over 121 is really like taking the square root of the top and the square root of the bottom. The square root of 81 is 9, the square root of 121 is 11. So do you see how this can be written as a fraction? 9/11ths, and all fractions are rational. So those are your perfect square roots. So this is a list of all the numbers that are rational. If you want to jot down examples, you can. Otherwise, just the words is fine. Now let's go over here to irrational. This means not rational. So the only kind of numbers that are irrational are going to be numbers where in their decimal form, they go on and on and on forever. So pi, absolutely irrational. Anything with pi, okay? So even if I take 3 times pi, I'm just tripling the fact that pi is an irrational number. Pi is a decimal that goes on and on and on forever and never repeats. So definitely pi. And then any square root that you don't know the exact answer to. So think square roots that can't be evaluated in your head. Okay, so for instance, the square root of 17, the square root of 2, the square root of 39. If you were to type any of these into the calculator, they're going to give you a decimal that goes on forever with no repetition. So if you see a square root that you do not know the exact answer to, like this, automatically irrational. That's it, you guys. That's it. Just these kind of numbers. Pi and square roots that you don't know the exact answer to. That's the only thing that's irrational. Everything else goes over here in this category. Okay, so that makes it pretty easy if you think of it that way. This is it, just these two things, okay? If you flip in your notes, you're going to see this page where you have a whole bunch of squared numbers and you have a whole bunch of square roots. This is a really good page to have filled out in your notes. It's very helpful because all of these square roots are rational. They're all square roots that you know the exact answer to, or you should at least. So maybe you know all the way up to 11 times 11 or 12 times 12, but these are also going to be important. So sometimes I tell students here when you go 13, a lot of times kids will know 13, 169. 14 times 14 is 196. So if you notice here, the 69 and the 96 are just reversed. So if you could remember 13 times 13, then you'll be able to do 14 times 14. We got 15 times 15 is 225, and then the 16. So I would pause the video and be sure that you fill out this list. That way it'll help you evaluate the square roots and also notice which ones are going to be your rational or perfect square roots, okay? All right, here we're going to look at some examples of where we are classifying radicals or square roots is what you know them as right now. Which of the following is an irrational number? So taking a look at the list, go ahead and circle what you think is irrational. Yep, absolutely. Answer B. Here we have a terminating decimal. Here we know the exact square root of 9 is 3. And here we have a fraction, and all fractions are rational. Nice job. Try number 2. Which of the following is an irrational number? Yep, you got it. Answer A. Notice how here this is exactly 7, this is exactly 5, and this is a terminating decimal. These are all rational. This one you cannot evaluate in your head. Try number 3. Well, you can't be both, and you can't be neither. You have to be either rational or irrational. Do you see how this is a decimal that repeats? We really could write it as 1/8 with a bar across the top. And all decimals that repeat can be written as fractions. You might have learned last year that if the 18 is repeating, 0.18, 18, 18, it could be written as a fraction 18 over 99. If you divide this in your calculator and change it to a decimal, you will get that. So it can be written as a fraction. That's why. So all decimals that repeat are rational. So answer is B. All right, try 4. Does the set of numbers contain rational, irrational, both, or neither? Again, you can't be both, you can't be neither. Here we have a whole number, fraction, perfect square root, and a terminating decimal. So yep, you've got it. They're all rational numbers. All right, moving up here to number 5. So you're just following along with me in your notes, hopefully. Which number is rational? Yep, D. You've got it. Here I have pi. Pi is irrational. Even if I multiply it by 3, it triples it. Here we have the square root of 17. It's irrational. You add it to 5, it's just going to be 5 bigger, but still irrational. Same thing with this. Square root of 21 is an irrational number. Here, 2 times the square root of 16 is 2 times 4, which is 8, and that's rational. On number 6, which number is irrational? Yep, B. You got it. Here I could evaluate this. This is really negative 16 times 2. This is a decimal that repeats, and here's a fraction. This one's irrational because of the square root of 74. That's an irrational number. You can't evaluate it. When you multiply it by 3, it just triples it, makes it 3 times bigger, but it's still irrational. On 7, which number is irrational when you multiply it by 5? So we want the number that's going to be irrational when we make it 5 times bigger. Well, this is the only number in the whole list that's irrational already. So if I make it 5 times bigger, it's just going to be an irrational number that's 5 times bigger. So it's going to still be irrational. On 8, which number is rational when divided by 3? Oh, sorry, I read that wrong. Which number is rational? I was thinking that didn't make any sense. Rational. Well, the only rational number in this whole list is B. So if I take this rational number and I divide it by 3, I'm going to get another rational number. In fact, if you take 1/3 and you divide it by 3, it's the same thing as multiplying by 1/3. You're going to end up getting 1/9. 1/3 divided by 3 is 1/9, which is a fraction, which is a rational number. So in order to get a rational result, you have to have a rational number to start with. All the other ones are irrational numbers. Okay, hopefully that was helpful. I hope that you feel like you can classify numbers as either rational or irrational, knowing that they can't be both and they can't be neither. Have a great day.